Like, I want to, but like, I'm afraid I'm not going to. So maybe I'll know.
And another day.
The other day.
Let's go to Joe's here. What
Plan night. Reaction.
Hopefully. I told my dad, if I get in, shoot a ton. Jack, are you still cutting your hair? He's like, I'm sure not cutting your hair. Are you still going to cut your hair? Yeah, I said, I'm popping 5'3".
I mean, I have to keep it for the ACP. Because you have to send in a picture. So.
I'm about to slam the squatter.
Alright, so all we're gonna do today, we're gonna take a few notes. At the very end of class, we will try to go on, and I'll try to give you some time where you can actually come out and finish that up. Remember, you need graph paper. Does anyone need graph paper for that?
Wait, can I ask for the notes?
Oh, yeah, we're not gonna need graph paper today for the notes, but you may have some. Yeah, a little bit.
Wait, so you know how we did all that crazy stuff
Yeah.
yesterday? Are we actually going to have to know?
Yes. We're gonna go once we get to the next section. Yeah. But I was also trying to explain it. All right. Hey. Okay. All right. We have 2 topics to talk about today before I let you kind of work on your homework. So, okay, we're moving on to section 2.4 today. Now, what this is, we're going to be dividing polynomials. We're going to be dividing polynomials today. And I want to try to explain this. Now, up until this point, we've done basic operations. If you believe it or not, we've done adding, subtracting, multiplying. We've done some type of division back in Algebra 2 days. But today, we're going to look at division in a little bit different light. What I'm going to do is I'm going to review how you did a division problem from Algebra 2. So I'm going to review an Algebra 2 type problem. Okay, and then what we're going to do today is we're going to intro how we use it in PreCalc. Because PreCalc, I think, this method we're going to learn today I think it's pretty awesome when you see it. But we need to have the basics down before we get there. Okay, so that's why I want to talk about an Algebra 2 problem. Now, before we get to like our pre-calc level dividing problem, I want to review some general math with you, which I know is a little silly. I do want to talk about a single general math type of division problem. Okay, just so you can see this, and then we're going to get into our new type of problem where we actually long divide. So this is kind of our goal today. Now, the whole purpose of this, like why we're doing this, is this one basic theorem that we need to discuss. It's called the rational zero theorem. So it's an actual theorem that we use in So we talked about the rational zero theorem. And that's going to be, this is going to lead us to why we do this. Okay, there's an actual purpose. And yes, if you didn't hear Jackie was asking, are we going to look at that problem we did yesterday on the board, like when we found those hills and valleys, the mins and maxes, those values? Yes, we are coming back to that. And that is something you really need to know how to do it. Okay, so now the reason why we're going to come back with why we're not going to right away, we need this first. This will make it easier. Does that make sense? So you don't have to go through such complicated work. Okay, so that's why we're going to make it a little bit easier to work with. Make this problem smaller, so we don't have that problem like what we were talking about earlier. It's like we did a whole problem in like one day. Like it was just one problem, and took the whole class through. This will make the problem way simpler. It'll make the problem smaller, so we don't have to spend as much time on it. Does that make sense? Okay. All right, so. That's what we're going to be doing today. I think today is pretty awesome when you see this stuff, but we're only going to go through a couple examples. We'll finish some examples All right, here we go. Let's talk about algebra 2 problem. All right. This is an algebra 2 problem, believe it or not. I do want to discuss this just so you can see this, and then I'm going to show you kind of the difference. Now, in algebra 2, this is what you have. How you were supposed to attempt to do this problem in algebra 2 was not start crossing out letters and numbers. Don't start doing that. What you had to do in algebra 2, if you don't remember, is you had to factor the top apart if you could. Okay? Is there a way that I can factor the top? Yes. How? Okay, good. Yeah. 2 parentheses, plus plus, 5 and 2, or 2 and 5, however you say it, x and x, right? It's a trinomial. So 2 parentheses, they're going to be the same symbol, they're both pluses. You break up the 10 to be 5 and 2 because that makes the 7 in the middle. And there you go. And then the bottom is the x plus 5, right? And what they teach you in algebra 2 is you just do this. Cross out the x plus 5. They're in parentheses, they're matching, you cross them out, so your final answer is this. That's what you did in algebra 2. Now, the reason why they teach you that in algebra 2 is because the whole time what you're learning throughout that class is you're learning basically how to factor. That's kind of the main purpose of algebra 2. That's why they spend so much time doing it. So many sections doing, story problems and whatnot. If you could get really good at factoring, it made the problems a lot easier to work with. Now, in this class, in PreCalc, we did a little bit of division. We did. It was, we did problems that looked something like this. X squared equals 7x plus 10. There was an x plus 3. Dividing by, x plus 5 and x squared minus 9. We did problems like this earlier the year. I think it was like one of our pre-req sections we did, where the only way we divided was we basically changed this symbol to multiplication, and what happened when we did that? Yeah, we flipped the second fraction, right? The second fraction flipped over like that. The first fraction didn't change at all. When we got to this part, and then what we had to do is we had to simplify. Before you multiplied everything together, what we talked about in class was like you factor this apart, you factor that apart, you factor the bottoms, and then you see if anything cancels top and bottom, you see if anything cancels diagonally, and whatever's left you go straight across. So let me go through that here. So on the top here, if we factor that apart, we just did it a little bit ago. That was the x plus 5, x plus 2, in no order. The bottom was an x plus 3. And then on the other side, that's a difference of squares. So the difference of squares is like plus minus. Okay, so 2 parentheses, plus minus. X and x, and 3. And x plus 5 is on the bottom, right? Now, the first check we always do when we did this earlier was we look top and bottom. Is there anything I can cancel out here? Nope. Over here? Nope. Now, we look diagonally. Yes. Diagonally we have x plus 5s, x plus 3s, and what we're left with is nothing on the bottom, so there's just a 1 down there. And so we're left with this. X plus 2, x minus 3. And if you wanted to boil those together, that's fine. But that's what we did. Correct? That's what we did earlier this year. Okay, and again, the reason why I bring that up, the whole point of that problem, what we did for prereq stuff, number 1, talk about basic operations, add, subtract, multiplying, dividing, but factoring. That's all we practice. We practice, breaking things apart. What happens when you can't factor it? Because that was something that I talked about the other day. It was like, finding the x-intercepts, or finding y-intercepts, or finding, when I did that crazy problem yesterday, where we did, the differential quotient. We got down to that crazy polynomial in the very end, and I put it over here, and I said, okay, if we factor this apart, we can figure out where the x values would hit 0, because we could factor. The problem is, everything we've done up to this point relies on your factoring skills. Can you pull things apart? I want to show you a problem that you can't pull it apart. And then what do we do then? Okay? So, I'm just going to pick one out of the book here. All right. write this problem down. I'd like you to write that down. Our goal today, our single goal, is to do that problem and simplify it as far as we can. That's minus 5. Okay, this is our goal today. If we can get to this problem today, we'll be done after we get to it. Okay? Now, if we try to attempt to do this like the way that we did in Algebra 2, or maybe earlier this year, right? We would try to break up the parentheses, factor it apart. The back here, we'd switch this to multiplication, and we put this on the bottom, right? And right over here, you factor this apart if you could. You break that apart. Now, is there any way to factor this thing? Looking at it. Okay, because you try grouping method, right? There's 4 terms. You try grouping method, so you put like an x squared for the first 2. I look at the back, and I have that minus 5x and plus 6. There's no way to factor that thing apart. Grouping method fails. There's no rearranging to it. It just does not factor apart. That's where we have to go to this new part today. Can we actually correctly divide polynomials? Because the crazy part is x minus 3 up there. That term. That is actually a root to that problem. It's actually one of the x-intercepts to that graph. X cubed minus 2x squared minus 5x plus 6. It is an actual root. It's an actual intercept. And without factoring it apart like we've been doing this homework here, we never would have known that. Never known that it would hit that spot on the x-axis because you've only been able to actually factor things apart to this point. So here's our goal today. I want to learn how to do that correctly. Can we simplify that, and can we figure out what the other remaining roots are? Because in theory, this problem has 3 x-intercepts. Or what they call roots, or zeros, whatever you want to call them. They have 3 x-intercepts, roots, or zeros. So the reason why I know that, there's power 3 on it. And so my goal is to try to show you that x minus 3 is one of the roots, one of those numbers. All right, before we get there, let's talk about how we do division for like pre-calc level. So to do that, I'm actually going to review general math with you. Because this is going to help us out. All right, 175 divided by 12. Okay, I don't know if you've ever seen this before. Maybe some of you are lucky enough to have actually seen this. What we're going to do to actually divide these numbers other than using a stupid calculator is we're going to do long division. Long division, okay? What long division entails is it requires that we use this like house, right? The first number here, the 175, this is what we call the dividend. It's the dividend. The number that we're going to put inside the house. The number in the back, what you're dividing by, that's called the divisor. The divisor sits on the outside of the house. Okay, how I remember this, the front number gets the house first, it locks itself inside, this is standing outside. That's how it works, okay? So, and that's the general math way that I explain it. It looks like that. Now, do you agree that it looks like a stupid radical symbol? I'm not doing a radical. I'm not trying to take the square root of 175. So don't think that I'm writing that. It's long division. So, if you've never seen this is how it works. You try to see how many times can 5 go into 175 without going over it. So how this works. You start with the front number. Can 5 go into the number 1? No, it's too big, right? So then you go to the next number. So can 5 go into 17? Yeah, 3 times like I heard. Okay? So 5 can go into the 17 3 times without going over. 5 times 3 is 15. And what we do is we subtract. Okay, it's the option multiplying, you add a bunch of things together. In division, you subtract. It's like the complete order. So 5 times 3 is 15, you subtract. 17 minus 15 is 2. And then for long division, you bring down the next item, the 5. That was the number I haven't used yet. How many times can 5 go into 25? 5 times. So 5 times 5 is 25. And when I subtract, you get 0. That means 5 times 35 is exactly 175. That's what you're doing. You're finding factors of this thing. That's what you're doing. If this divides perfectly, that's a factor of that number. Well, duh. 175 ended with a 5. I knew 5 was going to go into it. There's like little tricks and rules you can do. All right. Does the long division method make sense? Okay. Now, raise your hand honestly. How many people have actually done that before? Okay. So at least most of you have. Okay. Because you'd be surprised. Some people have never seen that before. They do like lattice method or scaffolding. I've never seen that before with division. This is how I've always learned how to divide. This is how I've always shown it. Okay. Now, make sense? Yeah. I'm going to use that structure to do that problem over there. That's what I'm going to do. That's why I brought this up. Okay. So here we go. So, which one's the dividend? The big thing, the one out front. So that's going to go in the house. X to the third minus 2x squared minus 5x plus 6. That's in the house. And the thing that's on the outside is the x minus 3. Make sense? Okay. Now, it's the exact same thing like what I did earlier. I'm looking at this item, and I'm trying to get it into this. And I'm going to explain the rules as we go. So, how many items are written out here? 2. So, when I divide, there has to be 2 things underneath it as I go. There always has to be 2 items below it. If there's not, that's too small. We have to drop another one. That's the type of thing. So, okay, so here's how it works. There's 2 items here. So I'm going to start 2 items over. That's how I have to work. So I'm going to have to go right here. So I'm going to start. What do I need to multiply onto this x that will make this thing? I need to multiply x squared, right? 2 more x's. So I'm going to take this item times x squared. What that'll do, taking this times an x squared, it'll make this item look like that. Does that make sense? Whatever the front item is. So if there's like a 4 sitting here, like 4x cubed, I'd have to multiply my item by a 4x squared to make sure that they look identical to each other. Agreed? Okay. So that's what we're going to do. We're going to multiply this item by x squared. So when I do that, what is x squared times these 2 items? What is x squared times this? What do I get? X cubed minus 3x squared. Does everyone see that? That's what you get when you multiply this onto this thing, which is that. Right? What I do right after I do that, I always subtract. Because that's how division works, right? I always subtract. So I'm going to put the negative sign here. And this will be a negative sign, which is because I'm subtracting. So I have to switch the sign, whatever it is. And now I go straight down. So what happens to my x cubed? Gone. Negative 2x squared plus 3x squared. 1x squared. Make sense? Bring down the next item like I just did earlier. And now we're starting the process. Now we're starting to see how this works. Okay? So now we start all the way over. What do I take times this to make it look like this again? X, a 1x, right? So a positive 1x. A positive 1, correct? Not like a negative or anything like that. You multiply it by 1, positive 1 to make it look like this. So if I multiply this thing by a 1x, what do I get? Squared minus 3x. Okay, draw a line. And now I'm subtracting it. I'm going to subtract and add. So yeah, so this will go away. This makes negative 2x. Okay? Drop down the next item. And now I start all over again. Okay, so what do I take times x to make that? Negative 2. I'm going to multiply it by negative 2 to make my item out here, this x minus 3, look like this. So when I multiply by negative 2, okay, I'm going to get negative 2x plus 6. Agreed? Because that would be a negative. So, okay, I draw the line, and now what do I always do? Subtract. So this will turn out to be a positive. This will turn out to be a negative. Because I always switch the signs. So that's gone. This is gone. My remainder is 0. So that means, since my remainder is a 0, that was a perfect factor of that thing. That means this was an x-intercept. That was a perfect x-intercept for that thing. So we actually hit the x-intercept. And what are the remaining two x-intercepts? This thing. That is the remaining two x-intercepts. So one of them, for this problem, one of the x-intercepts was an x minus 3. That was one of the x-intercepts. So this makes, positive 3 if we set it equal to 0. That's one of the spots where this graph hits the x-axis. Okay? The remaining two are this thing. So all I need to do is take that. That's my other x-intercept. And all I need to do is factor that apart, because that's easy. I can factor that now. Because all I need to do is break this down. This is the simplified version. So if I break this down, this will be plus minus 2 and 1, x and x, and that should make the 1x in the middle. And what will make this thing 0? Negative 2. What will make this thing 0? Positive 1. Those are my other two spots where this graph will hit the x-axis. There's 3 spots where it hits. It's at positive 3, negative 2, positive 1. Without being able to factor this, I would never have known that. I could not even attempt to factor that before. But there is 3 x-intercepts in this graph. And long division actually shows me this. Now you're probably wondering, okay, fine, you can do long division. We'll need practice with this. Trust me, we'll do economies. But how do you know, like if you were doing one of the problems from your homework, because they just give you a function, right? And they just say, hey, graph this thing. How do you know that that was one of them? Without just like randomly guessing, random numbers, right? That's where my property on the board comes in. This rational zero theorem. This rational zero theorem can help me predict what numbers I know are guaranteed to work on my problem. So like knowing when I was given this problem, I knew what numbers to pick from. Okay, that's the idea. Okay? Alright, and so that's what I want to discuss. I want to discuss how did I know that? So, let's go to that problem. What is that problem? 2x cubed, or x cubed minus 2x squared minus 5x plus 6. All right. So, this is the last thing I want to do today. How did I know that 3, or the negative 3 was going to work? Here's how you do it. This is called the zero root theorem, by the way. This is how I find what numbers will potentially be my zeros, or my roots, my x-intercepts. What you do is you take the number out front, that's the 1. You take the number out back, which is a positive 6. And what I do is I basically stack these numbers on top of each other. I take the back number, put it on the top, take the front number, put it on the bottom. Okay? And I can use any plus or minus of this. Now you're probably wondering, okay, that's, what is 6 over 1? 6, right? But what this is doing, this is setting up this right here, this fraction, is setting up for me to potentially have every single possibility of numbers I can potentially use. Okay, this thing right here. This. What I'm going to do to figure out what are the factors of this problem, all I need you to do is break up 6 and what are all the numbers that multiply to give me 6? What are all the different factors of 6? Yeah. 1, 3, 2, and 6, right? Those are all the different numbers that multiply to give me 6. What are all the different numbers that multiply to give me 1? 1 and 1, right? 1 and 1. So what I do is I take every combination of these, and those are my possible roots I can use. Those are the possible numbers I can use in this problem. So it's plus or minus. These are the possible roots. 1 over 1, which is the number 1. So it's any one of those two numbers. 3 over 1, which is just 3. 2 over 1, which is 2. And 6 over 1, which is the number 6. These numbers, what you're looking at, these 8 numbers, are the possible spots where I can hit the x-axis. And what I would do is I would pick one of them, like I did, the x minus 3, and I would try that one first. And I would try doing the long division. Since I can't factor this, I have to long divide it out. I have to try the positive 3 term. So I tried the positive 3 number, which was x minus 3. This is the parentheses that represents the positive 3. If I wanted to, I could have done this problem completely different. I could have picked one of my other numbers. What were my other 2 numbers that worked? Yeah, I could have picked this one. I could have picked x plus 2. That would have been representing this one. Been representing the negative 2 part. Okay, or I could have picked the positive 1, which meant x minus 1. I could have divided by any one of these 3 and it would have worked. Question?
What if you did an x minus 6?
It would fail. You'd get a remainder in the end. So you know it didn't work.
So you have to
Yeah, you have to restart. And now here's the thing. Like you're probably going, God, I would have to divide it 8 times. No. Because there's a trick that you can type in your calculator to know which one will work before you start. Exactly. Yeah, if you get anything but a 0, you know it doesn't work. That's the great thing. So that's what we're going to look at like tomorrow. Okay? Does that make sense? So this is what we're going into. Now I know like you're starting to see like a lot of this stuff and it's starting to get a little overwhelming. We're going to take them piece by piece. Today was kind of intro of what we're going into and why I wanted to show you that problem yesterday to today. We need this. This will help me narrow down problems so I can make them smaller. So I don't necessarily have to go overboard to figure out where all those peaks and valleys were and stuff. I can use smaller roots and smaller functions. Okay, questions? Okay. You have the rest of the time today. You can work on your page 312. We're going to come back to this tomorrow. Our goal tomorrow is to work on dividing. To work on practicing how to divide, how to do this stuff, to guess which numbers you should pick to divide by. Okay?
Ultimate math column.
What? Like we're doing all this stuff, you know, we really want to go as fast as they can, but I mean, we go fast. I'm the one slowing them down. I'm like, I'm like, read over this. Like, how do you know this? Like, I don't understand. Yeah, because this is great to read this. If you actually I still even got that like 2 weeks ago.
Yeah, I was so confused.
Probably. Just because considering the fact you can cost like 30 cents for a 16-liter bottle of pop, you can buy those for $2.
Does he ship it himself?
Yeah.
So how much does it didn't ship it?
I mean, it's literally just the stamp and like a letter. He doesn't. Yeah.
Why was it?
Pretty much just go to the website. Buy them off the website. I don't know, he's already got like 30 orders. Yeah, he said he's like, I got the idea from like a YouTuber. And he's like, literally spent $60 on 80 necklaces, and I made like 300 so far. Yeah. I walked in, I was like, yeah, I bought it off a friend at work.
Bring it over to question.
Jack, tomorrow, bring your donation can.
You guys, you make sure you guys do
If Eric doesn't donate, we will not let him play.
I agree. Have you found a pong table?
What?
Have you found one?
I think you can get one at Target.
Looks like you're going to
$189.
Kelly's telling me there's one at Target for $89.
What was that? Just
But
I didn't watch
Every
it.
time you put your phone in your pocket.
So what is it normally?
I like this thing.
It was really cheap. It was like one.
It's only this
20?
video like 150.
I think it's like 120 or 130.
My dad said he was looking at Craigslist once, and you know you can just get like the top, just the top of the table, and you get 7 months. And he said those are on there.
You can do
You
that.
get a
You
bunch
can
of
do that.
shapes.
Buy one of those party tables that are white. And
Yeah.
like,
I'm gonna be looking at yeah.
You can get all those tables instead of like $20.
You think it's big enough? I'd be able to make more than I make the parties in just a week.
Okay, is it just discount price?
Jack, look.
I'm heckling.
Garner, I don't know.
baloney. I have proof. Or don't give me that. Look, it's not due yet.
This is yours?
Of course
No,
not.
it's your mom's.
I got sidetracked. I'll do it
Can you
the
just
same.
click on one?
Yeah, right.
I
You're
will.
gonna be that one person that goes for it. I'm not.
Jack, I should
Coming tomorrow morning. I'm
I'm
actually gonna say that to you tomorrow.
I'll
What are you
get
doing? I'm gonna be like, more.
We can buy now then.
I'll get it.
Yes.
But I have them all. I have them all.
Scout outside.
I have them all set as
We need some skill.
coming soon.
Start out at 10.
Central strength. Be
Yeah, you have to go through a month. You have to do like a month of $10, add $1, and then do a month and see the difference.
Starting on
Crushing.
How many
What's that one dude? They're a good player. Austin. What's your cousin?
It's not up right now.
What?
I don't think. Try
$150.
shop.
Belmont. Willard.
Yes,
Belmont.
yes.
75. Dallas.
I just threw that around.
I can't tell it's Spanish, I can't tell it's just.
It wasn't even HTML.
Oh,
Your website.
Really? Yeah, that's it. It's like, it's green. It's green. No. False alarm. I think it was the 30.
so I found the best hat ever. It was a bucket hat. Oh, I have it on my computer.
I mean, you get some quick after that. Me on the stick. $50 in Garner, Iowa. But that's like the whole table.
Is it full?
Full way up.
That's not.
I should just snag it right now.
I don't have it up. It was
You like, can you see people like visit your website? Or like, we're gonna buy back.
yeah. You want route?
I'll tell him. I should just.
And you can have it.
Oh, it is like. $10 monthly subscription. What?
I should set up a self-job, honestly.
If there's something like that.
Set up two shops.
Mine is pretty fun.
What? I'll just buy it. I might just buy it. And I'll keep it. And then I can take it. You know what I mean? Instead of donating, because if we all donate this all, then it's just the church. I guess this is all.
Yeah, but
What
carry
I
it
would
around,
do
brother.
is you get your own
Yeah, carry that in your back pocket.
$10 and set up
I'll just
discount
check
rate.
it.
Take a coin, cartel that, the company just be discount rate.
Every single time I
We
did
talked to Mr. Ellen in our class today.
So that's why.
Or something. Yeah, but. Snag it. Come on, don't. I mean, opportunities like that don't just pull your doorstep every day.
Charles can be known.
Everyone needs to do that. Sit down, all stay with you. Gosh, I miss you.
Right now you have a burger.
like that.
So
It was like tied.
email for that,
Like,
and then we'll have to set that up to somebody's bank account, and then whoever has the PayPal.
I have a PayPal.
After we sell all of it or whatever.
I'm just kidding, I don't have a PayPal.
And however much total we get, we'll split it into
Easter
solid. Me and Jordan will do it. I don't know, I don't have a card, because I don't want to use my card yet.
Good. I was goofing, son. Hey, look here. Me and T.O. we found a pool table for $50. Not a pool table, be back. Ping pong table. $50. Yep. So we're gonna have Eric buy it, and then every time that we have a youth group, everybody brings $1, and we put it in the whole thing, and then we're gonna give him the money after we get $50.
That's a great idea.
What's that?
Okay.
But set it as this. So. And I'm just gonna have to walk it around. And I don't want to get late for class, so.
Can you run?
Yeah.
I ran.
That's what happens. You move a little bit too fast to eat. That's what happens.
I didn't take any notes from yesterday.
That's on for you today.
I'm gonna offer you some of that for the ones that I don't think you know.
It'll be normal by tomorrow. Alright.
Yeah. Good one, Tom. I played the 3-0 because I'm over-training myself.
I'm glad we're all on the same page.
Well, now you're giving me a rope. We're doing rope.
I'm gonna work tomorrow, right? Yeah. Okay, I got it done, but I don't have time to work today. I did too, so I came at 7:30 and got my book. I was like, oh my god. PG? I left my, I did too. Cause I'm here saying, oh my god, it's Tuesday. I like, you have my books, so I want to sit and find like everything. And I left my graph paper in my book. My phone's here. So then I went here this morning.
Yeah, but that means I have to take off my all my pants.
Why am I dying?
You know my leg is struggle.
When you press my
Okay, today we're going to take a few notes, and then I'm going to give you time where you can work on your assignment today. Okay, does that make sense? Okay, because I know it's due tomorrow, so I want to make sure you get some time. Now, we're not going to go through that extreme problem that we did yesterday. We're not going to do that. Okay, that's something we are going to come back to. So I need to preface that. You will